Good morning. Thanks to CitA for having us this morning. I'm just going to talk very briefly about a couple of the topics that were touched on earlier this morning. Productivity, looking at it throughout our industry, and in particular the Irish industry, and give some kind of facts and figures about the Irish industry, and also give a couple of case studies of how we within Henry J. Lyons as architects are trying to drive on that digital technology improvement and increase our productivity across the sector. Productivity, well, what is productivity? Productivity is the efficiency of converting inputs to outputs. I think earlier we heard about the effectiveness of productivity and the efficiency. So there's no point in having an efficient process if it's not going to be effective. So we need to have effective processes and become efficient in those processes. Right across the design and construction life cycle of a project, we have various inputs and outputs. For instance, the transaction between the client and the design team, we have an input versus an output. Between the design team to contractors, input versus outputs, and contractors to the final product. So it's ensuring that we have efficient, effective procedures and roadmaps in place to deliver that. If we look at productivity within the Irish construction industry, within the Irish economy, ICT at the start, we can see there's a significant improvement in productivity over 16 years. Next on the list we have agriculture, financial sector, public sector, and at the bottom of the list the Irish construction industry. So we're thereabouts with public sector. If we just take the construction industry, productivity pretty much level generally across 16 years. A couple of peaks there, not majorly significant. And then we overlay labour inputs. So again, as you can see, over the boom times, significant increase in labour. We fell off a cliff during the recession and significant decrease in labour. But productivity relatively stayed the same. If in fact you could say that slight dip in productivity during the boom times and a slight improvement in productivity during the recession. Obviously those that had employment were fighting for their jobs and become more efficient. So in terms of driving that efficiency and driving productivity, what do we need to do to improve that? So one aspect of this, and I think this is a topic that we generally spoken about quite a lot, is digitization, and we spoke about it this morning in depth. If we look at digitization across Europe, this was a study carried out by the McKinsey Institute. Digitization of the construction industry is at the bottom of the pile. Again, no surprise, digitization of the ICT sector is at the top. And again, relative to the facts and figures there from the Irish economy, ICT is at the top of the list in terms of productivity. So can we use digitization to improve productivity? Well, within Henry J. Lyons, I think just a brief overview of our practice. I think we have two offices, one in Dublin, one in Cork, approximately 200 staff across both practices, both offices. And we specialise in a number of areas: architecture, master planning, interior, workplace design, etc. Our client list, we have a number of high-profile clients, particularly within the ICT sector, Google being one, Symantec. So I think in terms of our own digital processes, in terms of looking at our clients and also our own internal procedures and digitizing those. And I think then developing our own strategy, which aligns with, as we can see here, leadership standards, education and training, and framing this around ISO 9001 in terms of putting a strategy together, having effective leadership in terms of developing a digitization strategy, putting the processes or the standards in place to drive that, and then in particular looking at the education and training, getting staff up to speed in terms of new standards. And I think the key here is the crosstalk between the different systems that we have within our office, using those systems, be it Sage in terms of our accounting software, cross-linking and talking to various different systems that we have. As a prime example, we have Revit as our primary BIM tool. We have that linked to our document information management system, Newforma. So we can issue documents or drawings directly from Newforma, from Revit, and then it goes straight into our project cloud, CDE, personalized CDE. We're also looking at Celibri, where now we can look at building regulation compliance and rule checks, and having design documents there and checks and balances in place in terms of building regulation compliance, right down to our Revit families, where we're looking at shared parameters, which we'll talk back to Celibri, and then having MBS Uniclass coding, which again will give us the standardization systems. A couple of case studies. I think probably most people might be familiar with this project, the Central Bank of Ireland. One of the design briefs in the Central Bank was to create a highly collaborative environment. So in terms of design, we're designing for collaboration, and we're looking at that in terms of utilization of the spaces and such. I think, you know, when you said about designing for collaborative spaces, I think the key challenge here was to deliver digital technology to align with that strategy. So here we have mobile working, encouraging people to become more collaborative in collaborative spaces in areas. So that involved, you know, moving away from your desk, moving away from your PC, having laptops, having tablets, and then having high-speed Wi-Fi, which will enable that digital workflow. And also then other challenges. So, you know, printing to the cloud, being able to pick up your prints or whatever from printers that are adjacent to those spaces. So highly collaborative spaces brought on technological challenges that we needed to address. In terms of design, in terms of the overall collaboration strategy within the design team, we're looking at a lot of different digital workflows, not just BIM, etc., but other aspects of the design in terms of, you know, fire analysis, CFD analysis, looking at smoke, understanding routes of smoke, solar gain modelling, you know, in terms of looking at that in terms of the overall energy strategy. It's a highly efficient building. It's probably one of the most energy efficient projects in the state. It has a BER rating of any A2. And then also thermal modelling, and then looking and linking the various aspects to thermal modelling, and then bringing on board sustainability, integrating it within the design process. So one of the most distinct factors of the building is its facade. The facade acts as a solar veil. It reduces the solar heat gain through the building, which then in effect reduces the amount of cooling that's required. Reducing cooling will reduce your energy loads. So moving on then into how we went about designing the facade, and then the processes that we put in place for manufacture and construction. You can see here our architectural models, breaking it down into parts, the kit of parts, understanding how they all fitted together, designing more efficiently in terms of understanding how each element worked and how each item fitted together more efficiently, right down to the contractors' models. So on the veil we have 3 different colours of a panel with 3 different perforations. So we had a simple matrix of understanding what colour went where versus its perforation size. Moving into manufacture, I think one of the key elements here was that we used our BIM models, or the manufacturer's BIM models, which were done through SolidWorks workflows, and then linked back into the design team via IFC and Revit. But the contractor got great efficiency in linking the design model that they had into their manufacturing processes. As you can see here, we have a veiled frame, just a long piece of an extrusion cut into 3 sections with a perforated panel fixed to it. We had a CAM machine which took that length of extrusion, cut it into 3, cut the miters, drilled it, have recesses for bracketry, etc. All of that process was automated. It's estimated by the contractor Architectural Aluminium that they saved approximately 1,250 man-hours. Those 1,250 man-hours are simply the reduction of a process from inputting a manual inputting from a CAD drawing into this machine and inputting that. It's just saying, okay, here's the model, pushing it into the machine. We didn't even incorporate or even look at any other aspect of this, because if we had to do this through more traditional methods, I think you could be adding 6, 7, 8 months to the construction program. We had 2,200 veiled panels with over 6,000 of these research brackets. I don't think this project could have been delivered on time at all, I think, if we didn't have this machine. So that they're hard figures in terms of savings and the processes coming from design into manufacture. We also had some lean processes on site in regards to clash detection coordination, clash detection meetings on site with various contractors, where we're able to test the contractors' models and coordinate those on site. Not just the old mentality of, well, you're the contractor, it's your responsibility to coordinate the work. It was done in a more collaborative environment where we had all the key stakeholders involved. Just one of our images from our clash detection models, at roof level we have quite a lot of plant, and we also had fire escape routing requirements, so we were able to clash detect the red fire routes against any elements that may impede on that. Another case study, it's a project which is currently on site at the moment, Cardiff Lane development, quite a large project, 4 buildings overall, done over 2 phases. Phase 1 is Block 3 and Block 4. Block 4 is currently under construction, it's adjacent to Facebook, and I'm just going to look at Block 4 at the moment. So we have six floors over ground floor and 1 floor of basement. We have precast concrete elements, modular construction, repetitive design in terms of the size and shape, and that spans around 3 sides of the building. Again, just an overview of some of our models that we use for the facade design. One of the unique elements of this was the method of construction that we chose for what we call the northern elevation. The northern elevation abuts onto the gable of the Malvern Hotel. We have 750 millimetres of a gap, probably not that much, between the gable wall and the finished wall of our building. So in terms of a construction challenge, how did we go about designing primary structure and building envelope to deliver on time and on budget? Well, one of the aspects that the construction methodology that we chose was an element what we call a sandwich panel. So it had a primary structure, 250 thick wall internally, insulation, and then an external skin, and that all came and were made in Techrete as a unit, came to site on the back of the truck and was craned into place, and literally we built it like Lego blocks. So you can see here we have the edge, so the red panels came in, put it up, floor sitting on top, next one came in, and on across. And that allowed, in terms of construction sequencing, it was pre-finished. It allowed speed of construction. and then it gave us the quality that we required in a very tight space. So I think, in terms of BIM design and then programming and looking at the sequencing, it was all done through our BIM models. I think one of the unique features of this project again was the work that was done by the contractors, specialists, Curtains, in regards to the repetitive design, the structural design and manufacturing drawings throughout the whole process. So again, you can see here in the various concrete elements, the rebar, the reinforcing steel was detailed. That was done in a way which allowed then the contractors to take that and to sequence that out via Dynamo script, which then took the repetitive nature of going through manufacturing drawings, hundreds and thousands of manufacturing drawings through the process, back through the process. We have the creator sitting down the back here, so I think it's very efficient. That then, the output of those in terms of rebar schedules, it linked into a machine in Techrete. The machine utilises coils of rebar instead of normal lengths of rebar, which you normally see on a building site. But the coils the coils are fed into the manufacturing machine and are just cut as necessary and required. They're all bent, they're all cut via the scripting requirements, and then it's literally split at the end with all the rebar coming in, and then they connect it all up into their necessary designs. So that takes efficiency, and I think in terms of the design, just the design alone, in terms of designing manufacturing drawings, it took, I think, something in the region of €30,000 saving within the first few weeks in terms of design outputs. So these are the key areas that, in terms of manufacturing, using digital technology to encourage productivity. Another aspect is a structural design that we have. We have cantilevering structure on the first floor, which is held up by steel, exposed steel, and then you can see here the design team's models, understanding how they all fit it together in terms of holding up concrete elements, right down to the contractors' models, and very highly detailed, but again allowed great efficiency in terms of understanding the design and looking at the sequencing to the finished product. So in summary, I think if we look at the BIM roadmap, which puts a target in place for 2021, 20% reduction in project delivery time, 20% increase in construction exports, 20% reduction in capital costs. I think they are all really achievable. In what just looking at some of the case studies that I've given there, I think if we really focus, if we work with the supply chain, understand what's out there, what are the capabilities, when we go through, in terms of production, procurement, I think we can, really achieve those. And finally, to leave you with a quotation from George Bernard Shaw: "Progress is impossible without change, and those who cannot change their minds cannot change anything." Thank you.